So how we define a term electromotive force or EMF? So basically, example, we have a battery or a cell and it is having two terminals. One is a positive terminal and the other one is a negative terminal. Inside a battery or a cell, there is a chemical reaction. So which form of energy it will have? It will have a chemical energy. And on the cell, it is labeled like example 1.5 V. It can be 1.5, it can be 1, it can be 1.3. So on the cell it is labeled 1.5 V. What is the meaning of this 1.5 V? It means if we connect this cell to a bulb or a lamp, and we represent the charges are coming out. So when the charges, due to a chemical reaction, charges are produced, and these charges get energy due to a chemical reaction. So the energy which each charge carry, that is known as electromotive force or e.m.f. So example, on the cell it is written 1.5 V. So what is the meaning of this 1.5 V? It means when the chemical energy produces the charges, each charge, 1 coulomb of a charge, how much energy it will carry? It will carry 1.5 joules of energy. Same way, if there is a battery or a cell and it is labeled on the battery that it is a 12V battery. So there is a chemical reaction inside inside the cell or the battery. When we connect the lamp or the bulb, so due to a chemical reaction, the charges will come out. So when this charge will come out from the battery or the cell, how much energy the charge carry, or it is energy supplied to 1 coulomb of a charge. So if it is written 12 volts, it means how much energy each charge carry. It means each charge carry 12 joules of energy. So electromotive force or EMF is basically work done on unit charge, or it is energy supplied to the charge to move the charge around the circuit. So electromotive force is measured by the energy dissipated by a source or a battery in driving a unit charge or 1 coulomb of a charge around a complete circuit. Or we can also say electromotive force of a cell can be defined as energy supplied to each coulomb of a charge within it. So example, a cell is there. On the cell it is labeled 3V. So what does it mean? If we connect wires and the circuit components such as like a bulb, so due to a chemical reaction it will produce charges, and when it will produce charge, like example, this is a charge which is produced. So when this charge will come out, how much energy it will carry? If it is at in 3 volt, it means this charge will carry 3 joules of energy. And the energy carried by 1 coulomb of a charge, what we call this, we call that as electromotive force, or in short you can say EMF. So EMF of the battery or the cell is refers to how much energy is supplied to a 1 coulomb of charge. So if we have a large battery, and it is labeled 6V, and we connect a wire, so when 1 coulomb of a charge, due to chemical reaction, there are charges produced. When this charge will come out, how much energy this charge will carry? This will carry 6 joules of energy, because how much energy each coulomb of a charge carry, or how much energy is supplied to 1 coulomb of a charge, we call that as electromotive force, or e.m.f. So if we have two identical lamps connected to two different batteries, one is 3 volts EMF, another one is 6 volts EMF, which case the lamp will be brighter, A or B? In which circuit the lamp will be brighter, or more voltage produced, more energy supplied by the lamp, A or B? So because in B the charge have more energy, so when the charge is having more energy, it will be brighter here in circuit B, and in circuit A the lamp will be dim. So electromotive force is simply the voltage of the battery or the voltage of a cell is known as electromotive force, or we can also say e.m.f. And if we want to calculate the EMF, we can calculate by using a formula the total energy supplied by the cell divided by the number of the charge flow through the cell. That is one way, or it is work done per unit charge. If you want to calculate the symbolic representation of EMF, this is this is not E, this is a Greek alphabet which is called epsilon. And the unit, we can say joules per coulomb, or we can also say volts. So joules per coulomb or volt is a unit of EMF, or electromotive force. So it's not the force basically. Electromotive force is not the force, it is basically the energy supplied to one charge, or 1 coulomb of a charge. That is known as electromotive force, or in short we can say EMF. So example, there is a cell, and this cell provide there is a cell which is providing the charges. Example, 5 charges are there, 1 2 3 4 and 5, and the total energy which each charge is, the total energy carried by the 5 charges, example, that is equals to 20 joules. So 20 joule is the total energy which they carry, and there are 5 charges. We want to find the EMF. So how to find the EMF, or electromotive force? So EMF is equals to energy, the total energy divided by the total charges. So if we divide the total energy by the total number of charges, so total energy supplied is equals to 20 joules, and the total number of charges are 5. So 20 divided by 5, what does it mean? 20 divided by 5 will be 4. So it means 4 joule per coulomb. What does it mean? The total energy is 20, and each charge, how much energy each charge is carrying? 4 joules of energy is carried by each charge. And what is EMF? EMF means how much energy is carried, or how much energy is supplied to one charge. So because one charge is carrying 4 joules, so we can say the electromotive force, or EMF, is equals to 4 joules per coulomb, or we can also say 4 volts. Same way, if we have a battery which is providing the charges, say three charges are there, and the total energy which the battery is supplying, example 30 joules. So the question is, what is EMF? EMF means electromotive force, or how much energy 1 coulomb of a charge is carrying. So to get the EMF, the electromotive force is equals to total energy divided by total charges. So what is the total energy? The total energy is 30. And how many charges are coming out from the battery? 3 charges are coming out. So 30 divided by 3. So 30 divided by 3 means 10 joules per coulomb. Means, or we can also say 10 volts. So what does it mean, 10 volts? It means that each charge, when 1 coulomb of a charge is coming out, how much energy it carry? It carry 10 joules of energy. Is it clear, the concept of electromotive force, EMF? Which means how much energy one charge carry when it is coming out from the battery. So another example, if we say we have a battery which is providing the charges in through a closed circuit. So there are 4 charges, and the total energy which they carry, that is equals to 60 joules. And the question is, find the EMF, electromotive force. So if you want to calculate the electromotive force or EMF, how to calculate the EMF? It's the total energy which is supplied by the battery divided by the total charges. So the total energy which is supplied by the battery, that is 60. And the total number of the charges which are coming out, there are 4 charges. So 60 divided by 4. So if 60 divided by 4, what we will get? We will get 15 joules per coulomb. It means, or we can also say 15 V, 15 volts. Volts also having the same meaning as joules per coulomb. So the EMF of this battery is 15 V. It means when one charge is coming out, how much energy that charge is carrying, that is known as 15 joules per coulomb, or we can also say 15 volts. So electromotive force or EMF, it is work done on unit charge to move the charge around the circuit. You have to learn these definitions as well. And when we connect the cells in series, so the total EMF will add up. Example, we have 1.5, 1.5 and 1.5. Three 1.5 volt cells are there. And this is a positive terminal, negative, positive, negative, positive, negative. So what will be the combined, or what will be the resultant EMF? 1.5 from cell 1, 1.5 from cell 2 and 1.5 from cell 3. And all want to transfer the energy in same direction, because positive to negative, positive to negative, positive. So all want to transfer the energy in the same direction. As a result, what will be the combined EMF? So it will be 1.5 plus 1.5 plus 1.5. So as a result, it will be equal to 4.5 volts. But what if we change the direction? So positive, negative, then negative, then positive, negative, and then negative, positive. We change the direction. So plus minus, and then minus plus. So as a result, as you can see, this is 1.5, 1.5, and 1.5. And before that, all were trying to transfer the energy in same direction, because plus minus, plus minus, plus minus. So they want to transfer the energy from positive to negative. So the direction was same. But now what happened? We connect them other way around. So this want to transfer towards the left hand side. This want to transfer towards the left. But this want to transfer towards the right hand side, means the opposite direction. So what will be the resultant EMF? So the one which is in the same direction, the one which want to transfer the energy in the same direction, we will add them, and the one which want to transfer the energy in opposite direction, we will subtract. So 1.5, 1.5 plus 1.5, and the other one is in opposite direction, so it will be minus 1.5. So what will be the combined EMF? So the combined EMF is equals to 1.5 volts, because these two plus 1.5 and minus 1.5 cancel, so we are left with only 1.5. So this is how we work out when cells are connected in series, one cell connected to the other, we can work out their combined voltage. Another example, positive, negative, positive, negative, negative, positive, negative, positive. And each is example 1.5. So this is 1.5, this is also 1.5, 1.5, and 1.5. They all want to transfer the energy, and that is from toward coming out from the positive. So the direction of energy transfer for this one is towards the left, positive, positive. Here towards the right. So when we work out, this is plus minus, plus minus, minus plus, minus plus. So when we work out, because these two cells which are on the left hand side, they want to transfer the energy in the same direction, so we will add them. These two cells want to transfer the energy in the same direction, we'll add them as well. But the two cells which are on the left hand side and the two cells which are on the right hand side, they want to transfer the energy in opposite direction. So as a result, what we do, we will subtract. So 1.5 plus 1.5, that is 3, minus 1.5 plus 1.5, that is also 3. So 3 minus 3, what is the resultant voltage? The resultant voltage will be 0. So in this case, they completely cancel out the effect of each other. Is it clear how we combine the result for cells connected in series? Any doubt till this point? But when cells are connected in parallel, so the total does not add up, the total remain the same. Like example, you have 1.5, 1.5 and 1.5, three cells are there in parallel. So the total energy which each coulomb of a charge will have, we will not add them. It will remain as it is, as 1.5. So in series only, that's why you will find, like if you have a toy or a remote control, you connect the cells in series so that the total voltage will increase. So combination of the cells are always connected in series to increase up the voltage. So example, we want to find the combined EMF of the following cells. So the question is, what is the combined EMF? So here, this is plus minus, plus minus, plus minus. So means that they all want to transfer the energy in the same direction. So this will be 6. Same way, the bottom will be 6. So all will be 6 here. So this 6 volt will be there parallel, then 6 volt, and then 6 volt. And in parallel, we don't add them, their voltage remain the same. So that only in series we add them. So 2 plus 2 plus 2, the combined will be 6 volt. Because for series only we add them, in parallel we don't add them because it does not increase or decrease the effect. So what is the advantage of connecting the cells in parallel? The cell will last for a longer period of a time, because when they're connected in parallel, they can provide the energy for a longer period of a time. So it will take longer before they need to be replaced. And it can provide a higher current, or more current can be supplied. So electromotive force, EMF, is simply the energy supplied by the cell. The second part is the potential difference. What is the concept of potential difference? Potential difference is energy transfer by the charge. So example, you have a cell or a battery on which it is labeled 3V, 3 volts. So when it is labeled 3 volt, it means when 1 coulomb of a charge is coming out, that each coulomb carry 3 joules of energy. And we connect two bulbs. So example, we have a 3 volt supply and we connect two lamps, lamp 1 and lamp 2. And due to a chemical reaction, there is a charge coming out. So first, what is the EMF? What is labeled on the cell is known as the EMF. So what is the EMF here? The EMF is equals to 3 volts, or we can also say 3 joules per coulomb. Means when 1 coulomb of a charge is coming out, how much energy it carry? It carry 3 joules of energy. When this charge start to move, because the charges transfer the energy, so before entering it was having 3 joules, but when it passes through the lamp, the charge has to transfer the energy. So charge will transfer some of its energy. Like example, when it before entering the lamp it was having 3 joules, when it passes through the lamp it is having 1 joule. So how much energy is transferred to the lamp? That is equals to 2 joules. So 2 joules of energy is transferred to the lamp. And how much energy is transferred to the lamp or the device, what we call that as a potential difference. We also denote by PD. So here what is the potential difference? Potential difference is equals to 2 volts. Same way, this charge which was having 1 joule of energy, when it passes through the second lamp, it transferred all of its energy and now it is having 0 joules of electrical energy. So how much energy is transferred by the charge when it is passing through the lamp? It will transfer all of its energy. Before entering it was 1 and after passing it is 0. So how much energy transfer? It transfer 1 joule of energy. So what we call that as a potential difference equal to 1 V. So and that charge will return to the battery with no energy to transfer to the component. So the energy which the charge transfer when it passes through the component we call potential difference, and energy which the charge get we call that as EMF, and energy which the charge transfer, what we call that as a potential difference. And the similarity between EMF and the potential difference, both are refers to joules per coulomb, or we can also say volts. Is it clear? The concept of electromotive force and the potential difference. Any doubt till this point? So the definition, what is the potential difference? It is energy carried by the charge and it consumed in the component like lamp, resistor, heater. What we call that as a potential difference, and it is energy divided by charge. The unit of the potential difference is also volts, or you can also say joules per coulomb. And if we want to measure the potential difference or voltage, so what we use a voltmeter. This is a symbol for the voltmeter, and this is how the voltmeter looks like. So another example, say we have a battery which is connected to different components. It can be any component. Like example, here in this example we have resistors. Two resistors are there, and the name of the resistor, example, R1 and R2, and it is labeled 10V. So what is labeled on the battery or the cell, that is known as the EMF. So what is the EMF? Electromotive force. It means it is 10 volts. And what is the concept of this electromotive force? It means how much energy carried by one charge. So when 1 coulomb of a charge will come out, there will be many charges coming out from the battery, but each coulomb, we are talking about 1 coulomb. So when 1 coulomb of a charge is coming out, how much energy it carry? It carry 10 joules of energy. So when this charge start to move, before it enter the resistor, it was having 10 joule. But when it passes through the resistor, it will lose some of its energy because the resistor will try to stop the charge to flow. So it will lose some of its energy. Example, it lost some energy and now it is 6 joules. So before it entered, it was 10, but now it is 6. So what is the total energy transferred by the charge when it is passing through this component? R1. What is the amount of energy transferred by the charge when it was passing through R1 or first resistor? Before entering it was 10 and now it is 6. So how much energy is being transferred? So the energy which the charge transfer, what we call that as a potential difference. So before entering it was 10, once it passes it is 6. So how much energy is transferred? It transfer 4 joules, or we can say 4 volts. Then before entering it is 6, and after passing through it is 0. So how much energy being transferred by the charge? So amount of energy transferred by 1 coulomb of a charge, that's called potential difference. So what is the potential difference or energy transfer? So before entering it is 6 and after passing it is 0. So it is equals to 6 volts. And then this charge will return back with no electrical energy to transfer. So the energy transferred by the charge is called potential difference, and energy carried by the charge due to a chemical reaction, we call that as electromotive force, or also known as e.m.f. Then voltage or potential difference in circuits. So when we work out the voltage and potential difference in circuits, in series circuit, the voltage will divide, where in parallel circuit, the voltage will remain same. So it is opposite of current. The current was same in series and in parallel divide, but voltage, it is divided in series. When two or more components are in series, the voltage divide. When they are parallel, the voltage will be same around them. So example, if we have say three components which are connected in series. This is a series combination in which we have only one way for the charges to flow. So in series combination, so example, if we say this was a 9 volts, so EMF is equals to 9. Voltage here is V1, voltage here is V2, and voltage here is V3. So example, energy transfer, because the total is 9 joules per coulomb, the total 9 joule of energy transferred by 1 coulomb. So example, if 2 volts is transferred here, 5 volts is transferred here, or example 4 volts is transferred here. So remaining is how much? 2 plus 4, 6. So remaining 3 volts will be transferred in the other. So the total is 9. So what happened? Basically what happened, like 9 volts of energy or EMF of 9 volts means there each charge carry 9 joules. So when it is passing through, before it is 9, once it passes through this first component, it it is now having 7. So how much energy is transferred? 2. Then before entering it is 7, and now it is 3. So how much energy is transferred? 4. And before entering it is 3, and after that it is having 0. So how much energy transferred? 3. So basically what happened, the charges when they are passing through the component, they transfer their energy. So whenever two or more components are connected in series, the voltage will divide between the component, or we can say that EMF is equals to V1 plus V2 plus V3. Like the voltage across the first component, second component, and third component, the voltage when we add them, we'll get the total voltage, which is equals to electromotive force or EMF. So in series, the voltage will divide between the component. Whereas in parallel, if two or more components are connected in parallel, parallel means the charges have multiple ways to pass through. So if we have a 9-volt supply, if they are connected in parallel, they all have the same voltage. The voltage will be same in parallel. What is the reason for that? Because 9-volt supply means when one charge is coming out, this carry 9 joules. But this charge cannot flow through each. So if example, if this charge follow path 1, so before entering it will be 9, and after passing through it is 0, and that returned back to the battery. So how much energy transfer? That is 9. But what about the second one? How it works? So there will be a second charge, another charge will come out from the battery, and that charge, if the first charge is moving through path 1, the second charge which is following the first charge will flow through path 2, and the energy it will transfer all of its energy, and then it will return back to the battery with the 0 joules of energy. So whenever two or more components are connected in parallel, they will have the same voltage. So the total EMF, if the EMF is 9, the voltage across first component is V1, voltage across the second component is V2. So when we write the equation, we can say the EMF is equals to V1, or that is also equals to V2. So remember, in parallel the voltage is same, and in series the voltage divide between the components. So that's why if we want to connect a voltmeter, we always connect a voltmeter in parallel. So connection of the voltmeter is always connected in parallel, because in parallel the voltage is same. So say we have components, resistors are there, and there's a battery or a cell. So if we want to connect a voltmeter to measure the voltage, so if I say we have R1, R2 and R3 are the three resistors, and we want to connect a voltmeter to measure voltage across R1, so we'll connect voltmeter across R1. If we want to measure voltage across R2, so we'll connect across R2. And voltage across R3, so parallel across R3. And if we want to measure the voltage across a battery or a cell, so we connect a voltmeter across the battery or the cell. So voltmeters are always connected in parallel. So this is about the potential difference and the voltage.